Okay, when we are talking about the angle of elevation, what do we have to have first? Would you learn? What do we have to have first? We have to first need a horizontal line. That's first. That's like the initial side. Ooh. From there, it rotates up to get a terminal side. The angle in between is the angle of elevation. So to have an angle of depression, we first have to have a horizontal. So we'll call that the initial side. From that, it's going to rotate down, making it an angle of depression. But we always have horizontals. So a surveyor, somebody that measures stuff that we can't just take a tape measure out and be like, oh, I'm going to measure the Washington Monument with a tape measure. That's not, we don't do them that way. A surveyor is standing 115 feet from the base of the Washington Monument. Okay, well, let's draw that. You guys know what the Washington Monument looks like? Who does not know? You guys ever taken, oh, do they even teach that stuff in history? I don't even know. It's like an obelisk, isn't that what you call it? Obelisk. There's some windows at the top of it. My entire life, not my entire life, a lot of my life, like 4 years, I lived in Maryland, really close to Washington, D.C. So we used to go to Washington, D.C. all the time. We used to take a train out there. It's pretty cool. And every time I went out there, the Washington Monument was closed. Sure. You need to see my Washington Monument. Oh, you need the original stuff? You really wanted to see my monument. Every time we used to travel out there, it was closed. Always closed for like renovation or whatever. And then about 10 years ago, about 10 years ago, I went and visited with my husband. We just took a long weekend and went out there, and it was open. I got to go for the first time. So I got to go see what's inside. It's really neat. Inside they have these carvings, these like plaques on the wall, and they have like one for every state. It's supposed to represent all the cool stuff in the state. It was really neat, but I think it's closed again. Has anybody been in the Statue of Liberty? You have been? Up there? Yeah, then you're very lucky because it's like never open. I got to see it one time too. They're always like doing stuff to it. I don't know. It might be open now, but it just seems like it's always closed. All right, I'm sorry. That was a very long off-topic conversation. The surveyor measures the angle. Oh, he is 115 from the base. So let's get this surveyor. It does not say it's a he. It could be a she. She's standing 115 feet away, and it says the angle of elevation to the top of the monument is 78.3 degrees. So there's this angle that is formed where this person is standing. 78.3 degrees. My picture is not to scale because that does not look like a 78.3. How tall is the Washington Monument? All right, so hopefully we know that distance connects to the base with 90 degrees. So I have to have a 90 degrees if I'm actually measuring the distance. We're trying to find the height, so I'll call it h. Now this is going back to the SOHCAHTOA days. It's going to be easy. Going back to SOHCAHTOA days. So angle that I have, and the side that I have, and the side that I need. According to this angle, what are these sides that I have and need? That's not my, that's where. What sides are these? What's H? H is the, it's according to this angle, H is the opposite. 115 is the adjacent. So we have a tangent ratio here. So I am going to be using tangent of an angle equals opposite over adjacent. So I'm going to plug in the information that I know. I know the angle is 78.3. I know the opposite. No, I don't know the opposite. That's H. And I know that the adjacent is 115 feet. You have to solve for H. Do you remember how to do that? Multiply what? 115 by what? Oop. Okay, so what Aliciana's saying is probably I do as well, but I do one extra thing to it just to help me when I have them set up a little bit harder. This is always going to be like one thing here and two things on the side when you use these. So I always put this over one, and then I cross multiply to solve. I multiply across that bridge. See that bridge in the middle? Cross multiply through that bridge, and I get 115 tangent 78.3 equals H. So we're solved for H. I just have to know what that answer is. So this is not one that I could do by hand because 78.3 is not one of our special ones, so I'm going to use my calculator. Names, you already get the answer. Good, I look forward to hearing it in a moment. What'd you get? So it's going to be an approximation because it's a horrible decimal. We can't get it exact. When I give you these on quizzes, tests, I will tell you what to round to. Your assignment today is in the book. I don't know if they tell you what to round to or not. I already posted the link, so you don't actually need the book. I already posted the link. But when I give you a quiz or a test, I'll tell you what to round to. Any questions on this? Did anybody not get 555 and then had to go back and be like, oh yeah, I was in radian form? Anybody? Couple. Everybody else thought of that right away? It's engraved? Good, good. I'm glad to hear that. All right, next one. You are in an apartment looking out the window while playing with your laser measure tool. You notice a car driving by 80 feet from your window. You also measure your window 40 feet above the ground. What is the angle of depression from you to the car? Because these are things you just wonder about. In your apartment window, playing with a laser measure tool. How high up are you? 40 feet? Feet up. The car is 80 feet from your window. So if the car is 80 feet from the window, where do I put the 80? Peter? And we need to know the of depression from you to the car. Do I have a horizontal line from you? Do you have it out yet? So better draw those laser eyes in. So that's the horizontal. And then to get an angle of depression, we have to angle down from the horizontal to the 80 feet. So that's where my theta is. I do have good news for you though. You took geometry. You passed geometry, yes? That's good. There's something that you learned in geometry that makes this a lot easier. And if you could just tell my geometry classes this is important, remember it because we're doing it in pre-calc. So from the horizontal line up top, I also have a horizontal line on the bottom. What kind of lines are these? They're parallel. So parallel lines. And what's this green line? Starts with a T. Yeah, trans. It starts with a trans. It's not a transformer. No. And when we have two parallel lines and a transversal, this theta, I could write somewhere else if I want. Liam, where can I write it? Right here? So these angles are the same because of alternate interior angles. So now let's look at this triangle. I have to find the angle, the theta. So inside of the triangle, theta would be this one. I know what information, this angle, what information do I know? I know opposite, and I know hypotenuse. And which trigonometric ratio uses opposite and hypotenuse? Sine. Sine of theta is opposite. So I'm going to fill in the information. Bless you. Sine of theta, 40 over 80. Sine of theta. What is it? 30 degrees. I didn't even need my calculator for that. Could we go over how to do it on the calculator, just in case it's one we don't know? Let's go over how to do it on the calculator, just in case. So if we're doing this on the calculator, sine theta equals 1/2, and you want to get theta by itself, what inverse sine. You have to inverse sine both sides. That the only thing that undoes something is its inverse. So inverse sine is the inverse of sine. So we're going to do that on both sides. And so on your calculator, you would do inverse sine 1/2 and get 30 for your degrees. But that takes way longer if it's one that I already know. Should be easy. All right, last section. This is, I said, we're going to have something that's just a teeny tiny bit new. This is the. You done bearings yet? Okay, I just want to hear no, because then I get to teach it to you my way. I guess they are in the past. This is what all my physics students tell me. Okay, we have bearings that tell direction, which is probably related to what you're talking about anyway. I'm sure it's related. It tells. So these are usually used in like surveying and navigation, like planes or boats. We're surveying the land. When we write always going to be the form of north or south first. It will be east or west last. And then the number in the middle would be the degrees of the angle. So for this first one, you always start at 0, 0. And you say, is it going to the northern hemisphere or the southern hemisphere first? Your choices are north or south. Go south. Then it goes towards the eastern or the western. It goes towards the eastern. And then this is where we end up with that line. So that's south, 35 degrees. So we went 35 degrees to the east from the south. Okay, the next one is north, 80 degrees west. So first we go north, then we go 80 degrees towards the west section. If I went north, 90 degrees west, where would I really be going? I'd just be going west, right? And this one is north, 45 degrees east. So we go north, go 40. Not going north, then east. The ship is driving at this diagonal. Okay, but this is how they measure in the middle of the ocean which way the ship is traveling. They measure it by comparing whatever it started at. This is like the starting point. And it says how much north and east we're going. Okay? So here's an example. I want to label some stuff on this one. So a ship leaves port at noon. Heads due west. Let me make it a little bit lighter because my shadow keeps getting it. Port at noon. Heads due west at 20 knots or 20 nautical miles per hour. Where's the port? It is at point A. How do you know that? Right. It's going west from there. You see where the ship is now. So the ship was going, this is going to be where the port was. Okay, so the ship was going this way at first. Okay, it says it's traveling at a distance of 20 knots or 20 nautical miles per hour. And then at 2 p.m., the ship changes its course. And before I get to this part where it changes its course, I want you to look and see what's going on here. If we start at port and we get to this point at 2 p.m., how long did the ship travel for? How do you get that? Because it left at noon. You gotta pay attention to the words that aren't written as numbers. So it left at noon, got there at 2, it traveled for 2 hours. And it's traveling 20 nautical miles per hour. We're traveling for 2 hours, we're going to get 40 nautical miles. That's the distance of that. So they have that written there. I just want to make sure everybody knows how we got it. So 40 is the length of that line. Now it changed course to north 54 degrees west, as shown in the figure. So now it changed. So you see right here how it has this north drawn in, but it's not going north. But from here, we're looking at north, and then from from straight up north 54 degrees to the west, that's the angle at which the ship is traveling now. Find the ship's bearing and distance from the port of departure at 3 p.m. So that's telling me that it has traveled more nautical miles. So this one's 20 long, this one's 40 long. We have to find the ship's bearing and the ship's distance from port of departure. So we have to find if this now is where we're going the bearing from. And this side right here is where the ship traveled straight. It didn't travel straight, but what we're trying to find is if it had traveled straight, what degrees? It's going to start north. It's going to go some degrees, and then also it's going to go which direction? West. So I just have to find that degrees in there. And in the picture, the degrees that I'm going to find will be this one here. Do you understand the situation, or is there something I did up here that you don't get? Yes, Lee. No. Neil. Well, if the port, let's say this ship is communicating with the port, and I don't know, the ship gets lost later, they can be like, well, we just communicated with them at 3 p.m. and they were at this bearing, and then they know how far away they were. Right. Like, what's going to be the shortest path to try to go rescue them? Right. Now, I don't really know the reason we need that information, but I'm just going to give you, like, hypotheticals. Like, I'm definitely not somebody that has ever worked this job, but I would say they probably need the fastest way and to get, to go there. And then probably from there, the rescue mission is a certain kind of radius, depend on some sort of other math equation. Right? So if you get lost on a ship, you want to be rescued, right? So math's important. End of story. Okay, let's go on. Just kidding. Not the end of the story. All right. So we need to find the distance that I outlined in purple, which they called C. And we need to find the angle, which I called theta. But they also, put a B and a D in there. Isn't that kind of interesting? They put B and D in there. It must be important. How are we ever going to find C? Let's plan this out. How are we going to find C? And before I call on you, do you know how to find a missing side of a triangle if it's not a right triangle? Do you know how? How could we split this? I mean, they have this one split, but this one would be a 90, but that one's not. So that was a good idea. But do you know a way? Do you guys know a way we can find missing sides? Yeah. Now, have I told you that stuff yet this year? No. That's coming, but we don't know that today. So today we're just working with right triangle trigonometry, okay? So we're not going to use law of sines, law of cosines yet. What they've done is they have created some extra lines over here so that we have a right triangle where C is the hypotenuse. So if we can see and we can see, then we can add D with this 40 and know that whole side. We can use right triangle trigonometry to figure it out. Okay? So let's try to find B or D. Let's find B. see, to find B, I know that there is a hypotenuse of this tiny little triangle. You see the tiny triangle? Should I make that in a different color? So now I'm looking at this triangle here. Find B. B is this side, looks like the small side of this triangle right here. I know the hypotenuse is 20. So I know the hypotenuse. I don't have an angle. Neat. What's 54? What angle? Well, 54 is here. Katie, which angle? CBD, yeah. Angle CBD. Measure of angle CBD is 90 minus 54. Oops. Because this is due west, and we know that this is north, so they have to be 90 degrees right here. So what is that? 36 degrees. I have too many colors now. 36 degrees. Okay, so we have an angle. That angle is located over by that point B. We have an angle. According to this angle, what is the side I'm solving for according to that angle? That's opposite. So what am I going to use if I have opposite and hypotenuse and an angle? Sine. So we're going to do sine of 36 is equal to B over 20. Cross multiply. Can you guys do this on your calculator, even if you're like, okay, I know what to do, I'll just let her do all the work? Because I want to show you something that maybe might, oops, I didn't have one on there. I'm going to show you something that might be helpful to you. Okay, so this is approximately B. So that's approximately B. But especially with the older calculators, we might need that information to find other stuff. And because I might need that information, I want the entire decimal, which you can call it 20 sine 36, or you can call it the whole decimal, whatever's better for you. But I want to show you can actually store this information. You could store it and then recall it. It's really helpful, especially if you have the older calculators. It doesn't matter so much with the newer ones because you can just go grab it. But I want to show it to you anyway because maybe you will find that interesting to store things in your calculator, because you can. To store stuff, there's a button down here that says STO. It has an arrow. Push that. And it should say, whatever this answer is, I'm going to store for you. So this was my side B. I'm going to store it as B. To store it, we do alpha, and then B, enter. It is now stored as B. Okay. So now I'm going to find, what's next? D. Same triangle, same angle, same hypotenuse, but D is the what? Adjacent. So that means cosine. So you can use 20 cosine 36 if we need it later. You can use that whole thing, or you can store it as D. Yes? You say it again. You what? You got a fraction? Let me calculator. Let me just type this in real fast though, and I'll come there. So again, to store it, I hit the store button, and then I hit alpha, and this is D, so I'm going to call it D, just to make it easier on myself. They're not nice numbers except for those ones that we know. Okay. So I got, what did I get? About 16.180 something. All right, so what's that going to do for me? Can we find C? I have to add what? I have to add 40 with D. Okay, so watch how I do that on here. Now, you could do that with answer also, but I'm just showing you it so you have this, just in case it's not so easy to remember these numbers. So I'm going to add D plus 40. Watch how I would add it. I would do alpha D, and then I would do plus 40, and it did it. It took that 16 point whatever and added it to 40 and got 56 point whatever. Okay, let's store that one. What should I store it as? Well, C is going to be that. We could restore it. I don't need D anymore. I can't store it as 2 letters. I can store it as X. Okay, so I'm going to store alpha X. Okay. So that side I'm calling X. This side I know is B. How do I find C? What? Oh, Pythagorean theorem. You guys kind of said it, but I couldn't understand. A squared plus B squared equals C squared. Except for it's not A. Oh, that would have been good to call it A, but X squared in this case. Right? So on my calculator, I can bring these things back up again. I can do alpha X squared plus alpha B squared. And then square root that answer. I could have put the square root in to begin with. Nope, that didn't work. And I got C to be about 57.397 nautical miles. One more thing. What else do we need? We need the angles for this bearing. So if I know, what angle can I find? Something inside the triangle. What can I find? What one in the triangle? D. Oh, AC. We can find DAC because we know all 3 sides of the triangle. So let's find measure of angle DAC. And then once I find that, I subtract it from 90 to get the theta. So measure of angle DAC is what we're going to find. According to measure of angle DAC, according to this angle, what sides do I know and have stored so I don't have to? I have B stored, and that is the opposite. And I also have my X, which is the adjacent. So what uses opposite and adjacent? Okay, so if I do tangent theta, and I do B over X, that means I'm going to have to do inverse tangent of B over X. But I've stored them, so it's pretty easy to do that. Inverse tangent, alpha B divided by alpha X. And I get 11.818 something. Does that seem reasonable for the picture? And you think? But that's not the answer. The answer would be the other portion of it. So I'll just take 90 minus that answer. Oops, got my minus. And we should have about 78.181. I'll just do 78.2 degrees. All right, there's one last thing. This is just saying that, and I think there's like one question, maybe two, in homework that talks about this. When we use air navigation, they don't do like north, west, or south, east, or something. They don't do the bearings the same way. It says it's measured in degrees clockwise from north. So if the plane is going from here, that would be 60 degrees. But we might write this as north, 60, east, right? But they're just going to tell you 60 degrees. So when you go to draw the picture, you have to know what that means. Or for this one here, they'll tell you 225 degrees. Where with the bearings, we don't even like use 90 degrees for bearings. But for air control, this would be like saying the exact same thing as south something west. What would that be the same as? $45. Right? We go this way, 45. So when you go to use information like that, you're going to have to use, if they give you just something like 90 degrees, you're going to have to know that. This is asking how far apart the planes are from each other, and it's also telling you that they fly for 20 miles. Wait, one of them flies for 20 miles. Oh, and 50 miles. There you go. So you're learning, like this one right here is oh, these don't go to that. I'm sorry. If it flies a bearing of 90 degrees, where would that be? Sorry, I'm not on the screen. If it flies a bearing of 90 degrees, here's an airplane taking off right here. It flies a bearing of 90 degrees. Where will that go? Okay, so straight up means 0 degrees for the air traffic. So it's going to go east for 20 miles. So that would be the first plane. The second plane has a bearing of south, 35 degrees east. So south, then 35 degrees east. And it flies for 50 miles. And the question is, how far apart are the planes from each other? Which, I don't know that, well, yeah, we're not going to get to this one. So you might have questions when you come in if there's one like this. I will see if I get it to the other class, and if so, I'll record just a separate video of just this one. Here's the assignment. It is on Canvas. It's probably what you're waiting on, huh? Shoot. It is on Canvas.
Attention, Mr. Clint's fourth period class. You should report to room 187 for fourth period. You will not eat A lunch today, but will eat C lunch. Attendance will be taken for A. Again, Mr. Carson, please, fourth period class report to room 187.
Mine are
Thank you.